Hello there and welcome to Lower 6th Further Maths A-Level January Mock Exam Revision Sheet 2. Here we're working on question 6, a series question. Show that the sum from 1 up to n of r plus 1, r plus 2 is equal to this formula here. So what we have to do here is, well, first of all, leave ourselves lots of space. Okay, so what we're looking to do is use the formulas that we've remembered from completing this topic and using them to help us prove this expression here. So the first thing we need to do is to split up our brackets here and unfactorize what we have. So we're going to get r cubed plus 3r squared plus 2r. So once you expand the brackets, this is what you'll get. And then what we do is we split up these three separate summations just like this. We're going to factorize out a 3 to the front of this expression as well. And factorize a 2 out to the front of this expression as well. And now we're going to recall all of the formulas that we have for these expressions here. So for the r cubed one, look into your formula booklet and you see this one will be n squared over 4, n plus 1 squared. The next one's going to be n over 6, but it'll be times by 3, so it'll be 3n over 6, n plus 1, 2n plus 1. And then for the last one here, it's going to be plus 2 lots of n over 2, n plus 1. Okay, so we see here the 3 and the 2 have had to be multiplied at the start of their formulas because they have to be included as well. Right, what I want to do next is to create a common denominator in all of my terms here out of the 4, 6 and 3 so that I can easily factorize out that common denominator. So what I'm going to do is I'm going to create a common denominator of 12 on each of my expressions here. So on the first one I'll have to times up by 3. On the second one here I'm going to have to times up by 2. And on the last one I have to times up by 6. So 12n over 12, n plus 1. Right, okay, so now comes for the big factorizing step once I've now factorized the denominator here. So this is going to be over 12. Right, so we have, looking out for common expressions between all three of these terms now. We have an n in common to all three of the terms here, here and here. So we're going to have an n. We actually also have an n plus 1 in common to all three of the terms here, here and here. So I can pull out that to the front as well. Now what I've got left over is 3. We need another n inside this bracket to make the n squared, and we need another n plus 1 inside this bracket to make the n plus 1 squared. Then we're going to add 6 lots of, well, we've already got the n, we've already got the divide by 12, we've already got the n plus 1, so it's just 6 times 2n plus 1. And the last one here, we've already got the n at the front, we've already got the 12 at the front, already got the n plus 1 at the front, so it's just going to be plus 12. So this is going to equal n over 12, n plus 1, bracket, 3n squared plus 3n plus 12n plus 6 plus 12, so just expanding the brackets here. Okay, simplifying the algebra here, we're going to have n plus 1, that's going to be 3n squared plus 15n plus 18. Right, so to me, just from observation, I can see that all three of these values here are going to be divisible by 3. So factorize out a 3 to the front, and we'll get 3n over 12, n plus 1, n squared plus 5n plus 6. Okay, let's simplify this now. 3 over 12, that will give me n over 4. Next one's going to be n plus 1, and then factorising the end bit here, n plus 2, n plus 3. Perfect, that's just what we want part A. Part B asks us to evaluate 3 times 4 times 5, add 4 times 5 times 6, add 5 times 6 times 7, all the way up to 40 times 41 times 42. Now, I don't know why they would have asked us this unless we were expected to use part A in this calculation here. So, just from looking at this first part here, if I can match up this expression here with my summation, then that would be great. Let's say that r is 3, r plus 1 will then be 4, and r plus 2 will then be 5. Great. For this one here, the same thing works. If r was 4, then r plus 1 would be 5, and r plus 2 would be 6. So what this summation here is representing is the sum from r equals, well, the first number I start at, the first r number I'm using here is 3. And the last r number I need is 40. So it's going to be r from 3 up to 40 of r plus 1, r plus 2. Okay, so the difficult with this bit here is we're not starting our r value at 1 like our formula asks us to here. So we're going to have to split up this formula. So the summation from r equals 1 of r plus 1, r plus 2. And we're then going to have to take away the summation of r equals 1, and we need the 2 one as well. That way we'll leave the 3 summation up to 40 left over. So r plus 1 and r plus 2 will also be needed. So using the formula to calculate most of this, so now that I've got my summations down to 1, we can use our formula. So 40 over 4 times 41 times 42 times 43. Take away 2 over 4 times 3 times 4 times 5. And if you bash that into the calculator, you get the answer of 740,430. Let's just check that on the calculator. So what we can actually do on our calculator is just use the first summation to help us work this out. So what I can do here is by pressing the shift button and then the X button in the top right, I can highlight this series function button on my calculator that will help me do a lot of the work. Unfortunately, I can't use R's, so for my formula, when I type in my formula, this bit here, I'm going to need to use X's. So it's going to be X bracket, X plus 1 bracket, bracket, X plus 2 bracket. And it goes from 3 up to 40. I can change those bottom and top numbers as I wish just by using this control pad arrows here. Type that in and you get the same answer as you did the other way, just as you would expect. Great, 7 marks.